Hello, welcome back to LK Tuition. My name's Lucas and today we're going to be looking at proof. Now when I design these PowerPoints they always give me ideas of what they think the background should be based on what I've written in the title. So I've written proof and they thought, hey, you want a video of a parrot? I thought, yeah, why not? Definitely do. There's a parrot looking around. Don't know how long that video goes on for, but hope you are well. And we're just going to do loads of examples of proofs. It's hard to kind of explain how to do them, so I kind of just do loads of examples, try and give you tips and tricks as we go along, and we'll see how we get on. All right, that parrot is intense. Okay, so number one, we want to prove algebraically that the sum of any two consecutive integers is always an odd number. So with a proof, the kind of statement of the proof always gives you like the beginning of the story and the end of the story, and it's your job to fill in the gaps. So we want to prove algebraically that the sum of any two consecutive integers is always an odd number. So the start of the story, we want to start with two consecutive integers, give them names, give them algebraic names, do a little bit of algebra. There's usually only like one thing you can do, to be honest, and then hopefully by the end we can see that that is an odd number. So let's start then. So with this we want two consecutive integers. So let's just give it a name. So let n be an integer. Well, if n is an integer, the next one, the consecutive one, the next one would be n plus 1, because an integer is a whole number, so whatever n is, the next one will be n plus 1. So the sum is going to be n plus 1. Yeah, so you've got n plus the next number, which is n plus 1. Now all we can do now is simplify this, so we can bring the two n's together, so 2n plus 1. Now can we go from there to it's odd? Well, we can, because 2n is even, because it's 2 times something. 2 times anything is an even number. So since 2n is even, 2n plus 1, the next number after an even number is always odd. Okay, and that's the first one. So you start with what you've got, do a bit of algebra, and then hopefully get to the end of the proof. Okay, number 2. Prove that 3n plus 1 squared minus 3n minus 1 squared is always a multiple of 12 for all positive integer values of n. Okay, well this one, it's already given you a formula, and the only thing we can do with this is try and expand it out. So let's just expand this out then. So 3n plus 1 squared, so there are other videos on expanding double brackets, so I'll just do this quite quickly. So this is going to be 9n squared plus 3n plus 3n plus 1, and then minus, and I'm going to minus everything in here in a minute, but this is 9n squared minus 3n plus 1. Then if we kind of bring some terms together, we've got 9n squared plus 6n plus 1. And then if I just minus everything in here, we're going to get minus 9n squared. This minus 3n and minus 3n becomes minus 6n, but then I minus it, that's going to become plus 6n. And this plus 1 is going to become a minus 1. Okay, now I've got a few things that are going to cancel. So we've got 9n squared here and minus 9n squared there. And we've also got plus 1 and minus 1. So all we're left with is 6n plus 6n, which is 12n. And since it's 12 times something, it's obviously a multiple of 12. So you can say which is clearly a multiple of 12, since it's literally 12 times something. Okay, great. Let's do another one. Okay, so number 3, we want to prove algebraically that the sum of n plus 1, n plus 2, and n plus 2 is always a square number for all integers n. So again, let's just do this sum. So we want n plus 1, n plus 2, plus n plus 2. Let's keep that in brackets. Now we could expand it and simplify it, but actually I'm going to factorise. We're going to do a factorisation. Now, because in both terms we've got n plus 2. So let's factor out n plus 2. So it's n plus 2. And what's in my brackets? Well, we've got n plus 1 on the left, and we've just got 1 on the right. So it's n plus 1 plus 1. But what is n plus 1 plus 1? Well, 1 plus 1 is 2. So this is n plus 2. And this, well, this is just n plus 2 times itself. So this is n plus 2 squared. And that is a square number. Yeah, so because it's something squared, which is clearly a square number. Pardon my writing. All right. So you could have expanded these brackets, brought in the like terms, and then you'd have to factorise a quadratic. But here what I've done is I've just noticed that there's an n plus 2 in both terms, factored it out, simplified the next bit, and it turns out that it's squared, which is what we wanted to figure out all along. Okay, number 4, we want to prove that the sum of 3 consecutive odd numbers is always a multiple of 3. Okay, so we want 3 consecutive odd numbers. Well, what is an odd number? Well, any even number can be written as 2n, and any odd number can be written as 2n minus 1. Now, the reason we do 2n minus 1 and not 2n plus 1 is because 2n plus 1, you're never going to be able to get the number 1 from that if you put in whole numbers, positive numbers. So we put minus 1 so that if you put 1 instead of n, you'd end up with 1. So that covers all of the odd numbers. So this is the first odd number. Now we want the next odd number. Well, so we want to add the next odd number. Now 2n minus 1, then the next number would be 2n, but that's even. And then the next number would be 2n plus 1, which again is odd. And then finally, we want to add the next odd number, which would be 2n plus 3. Okay, and now we want to prove that this is a multiple of 3. Well, let's just count everything we've got. How many n's have we got? 2, 4, 6. So we've got 6n. Minus 1 and plus 1 cancel, and then we're left with plus 3. Now we want to prove this is a multiple of 3. Well, you can see that it is, because we've got 6 of something and 3 of something else. But if we factor out 3, it'll make it a bit clearer. So 3 brackets 2n plus 1. Yeah, and that's a bit more obvious that it's a multiple of 3, which is clearly a multiple, of 3. Okay, all right, we're doing pretty well. I think we've got 2 more to have a look at. So number 5, prove that the sum of the squares of any 2 consecutive integers is always an odd number. Okay, so let's start with, so let n be an integer. Now we want the sum of the squares. So we want to square this and the next consecutive integer. So then n squared plus n plus 1 squared, and that's what we want to do, the sum of the squared. So this is going to be n squared plus, if I expand this and simplify it, I'm going to get n squared plus 2n plus 1. Okay, and then this is going to be, well, we can bring the 2n squareds together, so this is 2n squared plus 2n plus 1. Okay, well, how can we prove that this is odd? Well, the 2 on the left are both even, aren't they? So they're going to add to make an even number. And then if you add 1 to that, it's going to be odd. So we can make a little bit more of a step. I'm just going to factorise these 2 first terms. So 2 brackets n squared plus n plus 1. So that's telling me it's 2 times something plus 1, which is odd. Okay, great. All right then, and then one final one to have a pop at. So we want to prove algebraically that the sums of the squares of any 2 consecutive even integers is always 4 more than a multiple of 8. Okay, so there's a lot going on here, but let's just put it out in steps and we'll see where we go. So we want to start with 2 consecutive even integers. Okay, So we'll say 2n, yeah, being an even integer. So the next one would be 2n plus 2. So we want to do 2n squared plus 2n plus 2 squared. So sums of the squares. Then if we do that, so 2 squared is 4, n squared is just n squared. This is going to become 4n squared plus 4n plus 4n, which is 8n plus 4. Then I can bring the n squareds together, which is 8n squared plus 8n plus 4. Now this is looking good. So 4 more than a multiple of 8. Well, if we just factorise the 8 out of the first two terms, plus 4, and that tells you that it's 4 more. So let's write this down, which is 4 more than a multiple of 8. Okay, so I've done quite a few examples there, but hopefully you're getting kind of a feel for them. Just take what they've given you, give it a letter, and do what they say. So sum of the squares, or sum them all, the difference, or whatever. And then a bit of algebra. There's usually only one step you can take, expanding the brackets or something like that, and hopefully you can end up with the answer that you need. Okay, this has been LK Tuition. Please remember to like and subscribe, and I'll see you soon for some more maths videos.